You know, most of us drive over them every single day without a second thought. But all across America's 600,000 bridges, there's a really serious problem brewing. And trust me, it's probably not what you're thinking.
We tend to worry about the stuff we can see, right? You know, rust, maybe some cracks, crumbling concrete. But what if the biggest threat, the real danger to our bridges, is completely invisible? A hidden force just silently building up inside the very structures that are meant to keep us safe. So let's start with a number, a pretty startling one, nearly 40%. 40% of what, you ask? Yep, that's right. According to the U.S. Department of Transportation, basically 4 out of every 10 bridges in the entire country need some kind of repair work. And this isn't some problem for the future. That clock is ticking down as we speak.
So to really wrap our heads around just how big this challenge is, we have to dig into the numbers a little bit.
And wow, the numbers, they're pretty staggering. The average American bridge is 45 years old, which means it's really pushing the limits of its 50-year design life. And get this, just to clear the current repair backlog would cost an extra $8 billion a year for the next 50 years, and that's just to play catch-up. But look, aging and underfunding, those are the problems we can see. Remember that invisible threat we talked about? Well, it turns out it's being supercharged by our changing climate. Okay, so to understand this, we need to zoom way in on this tiny but absolutely vital part of a bridge, the expansion joint. Think of it like a breathing gap. When it gets hot, the bridge expands, and this joint is what lets that happen safely without putting a ton of stress on the whole structure. But here's the thing, it's so simple. Those joints get clogged up with all sorts of road debris, sand, dirt, you name it. And that breathing gap, well, it gets sealed shut, and all of a sudden the bridge can't move the way it was designed to.
So here's the chain reaction that happens. The sun heats up the bridge, right? And thousands of tons of steel and concrete try to expand. But that clogged joint, it's like a solid wall now. All that thermal energy has nowhere to go, so it turns into this immense compressive force, just silently building up inside the bridge's main supports.
And this is where we find a really critical design flaw. Bridge supports are built to handle force from above, the weight of cars and trucks pushing down. What they are not designed for is to be squeezed from the sides by this massive horizontal force. It's kind of like trying to crush a soda can by pushing on the top and bottom instead of just stepping on it. It's a force they were never ever meant to fight.
And this is exactly where climate change becomes what they call a threat multiplier. And the impact can be measured by just a single degree.
Get this. For every 1 degree Celsius increase in the daily temperature range, that dangerous sideways stress on the bridge goes up by about 2%. So as our climate warms and these temperature swings get more and more extreme, this hidden danger just gets worse and worse, year after year.
So how do we fight back? How do we take on this invisible threat and that massive repair backlog? Well, it's not just about spending more money, it's about working smarter. One of the biggest hurdles in bridge repair is just getting to the problem in the first place, especially for foundations that are sitting underwater. Trying to create a dry, safe place to work has always been really difficult, slow, and just incredibly expensive. But check this out. Clever innovations like this are totally changing the game. This is an inflatable cofferdam. It's a reusable barrier that, and I love this, uses water to hold back water. It can be deployed super fast to create a dry work area, letting crews get in, make the repairs, and get out, saving critical time and money.
Okay, so repairs are crucial, but that's a reactive approach. What if we could proactively monitor the health of our bridges in real time and on a massive scale? Well, a revolutionary new approach is doing just that, by turning our existing internet infrastructure into a giant diagnostic tool. So it turns out we have millions of miles of fiber optic cables that already run right alongside our roads and bridges. And scientists have figured out how to send laser pulses through these cables and then read the light that bounces back. Tiny vibrations from traffic or even structural strain actually change that reflected light, letting them measure the bridge's movement with incredible precision. It's a technology called distributed acoustic sensing, and it literally turns the internet itself into a giant sensor.
And the accuracy is, well, it's just remarkable. I mean, when you compare it to older monitoring techniques, this new DAS method gives a way clearer picture of how a bridge is actually behaving under the stress of daily traffic.
But the biggest advantage, the thing that makes this a true game changer, is this. As the researchers themselves put it, quote, "This approach does not require installation and maintenance of dedicated sensors on bridges. We can just tap into the network that's already there. It makes large-scale continuous monitoring a cost-effective reality for the first time."
So when you think about it, from something as simple as just keeping those joints clean to leveraging our entire global communication network, the tools to fight this hidden danger are really within our grasp. It leaves us with a pretty fascinating question. Could the network that connects our world also be the key to protecting it? The very infrastructure carrying our data might just be what saves the infrastructure that carries us. Thanks for watching.